Hey, okay, excellent. So we're live, and hopefully someone will join or watch it later. But this is introduction to Git and GitHub. It will be as gentle as I can make it, because those are very complicated topics. So if you don't get everything, it's not a problem. It's more about showing you the potential of it, so you can kind of learn more about it at your own pace at home using other resources. And basically learning by doing, as always, is the most efficient. So I'm going to show you Git from perspective of a receiver. Perspective of a, well, no. Right, cool. So this is my GitHub account, and this is, I'm in GitHub. Okay, I'm gonna log out, so it'll be the same as yeah, I'm gonna make it bigger. So the most common way that people actually learn about Git and GitHub is when someone tells them, hey, my software is on GitHub, just grab it and use it. Yes? Yes. And then you go on this thing and you have to create an account, and it's all confusing, and what do you do with it? And now I'm going to show you that perspective. Basically, we're going to start with that, and then we're going to actually start putting something on GitHub, using Git, and understanding what is Git and what's it for. But to kind of give you the introduction, the context of it, Git is something that we call a version control system. So it's for keeping a history of edits of your files, which is very useful when you code, because you can easily go backwards in time, you can reverse changes, and you are tracking all the things that happen to your code base. It's also very useful for collaboration, because multiple people can contribute to the same file, and thus project can grow because more people, more growth. But from the initial perspective, we basically just want to get something from GitHub. Okay, so to actually get something from GitHub, you don't need to have a GitHub account. Most of these projects are public. There are some private projects. To gain access to those, you do need to have a GitHub account, but we're not going to focus on them for now. Okay, so let's look for a package. For example, someone told you about this weird thing called NiPipe, and you want to download it. It's not a perfect example because NiPipe is available through other means that are much easier to install, but let's assume those means do not exist. So let's try to get it from GitHub. Okay, so I'm searching for a name in GitHub, and you see that there are multiple projects that include that name. This is the one that we are interested in. And as you can see, we'll list all these files here. And this is the content of the software. And many of the projects will have some documentation describing what's going on and how to use this project. And you can also look at commits. So this is the history of the code evolution. One comment is one snapshot of the code. So you can see that there's been quite a few of those, actually 7,000. The project has been going for a long time. Also releases. And here, if the project is maintained well, you would be able to actually download stuff. So you can just click here and download this on your computer. And depending what kind of software is it, you can use it. If there are no releases, there are projects without releases. For example, it's T2Z, I think. Is that project? No, sorry. T2Z. Yes. So that's a very small project that is implementing a more accurate way of converting T values into Z or Z values. And this one, well, it does have a release, so we can download it this way. But let's say you want to download the bleeding edge. So that release, let's have a look. The release is from 16th of March, but the last commit was 2 days ago. So there's a more up-to-date version of this code that is newer than the release. So how do we get it? Basically, what you have to do, you have to clone your repository. So you take this URL in this box, you copy it, you just copy that URL, and then you open a terminal. So just open a terminal here. Is that visible? Is that big enough? Yeah. And now I'm going to go to a folder. Go to a folder. Okay. And if the folder that you want to actually store your software, and what I'm going to do is git clone. Clone, and I'm going to paste that link. What it will do now, it will download this piece of software together with all of the history of all of the revisions. So I do that, and it's cloning, and it's downloading it, all right, and we're almost done. While this is happening, I don't know why it's so big. Well, anyway, so this happened, and now it created a folder with the same name as the repository. I can go to this T2Z, and I can see it. Okay, excellent. But let's say I'm gonna use a different piece of software. I'm gonna look for NeuroSynth. Okay. And my wonderful assistant here will help me out. So I'm gonna clone NeuroSynth the same way I cloned that other tool. But after I'll clone it, my delightful assistant, okay, I'm cloning this. So after I finish cloning it, hopefully it will not take too long. We'll make a change or a small update in this repository. And I'll show you how you can update your code with Git. Yep. So this is done. So I have a, let's say maybe you can, so I can go to NeuroSynth. So this is NeuroSynth. This is the same code you saw on the GitHub page. Let's say it will be a meaningless change. Let's say you can add something at the end of the README. Could you do that now and push it to GitHub? So here you can access all the different tools that you have on GitHub as well. So I can do git log, for example, and that tells me those are the different snapshots or comments that were been made to this code base. And from here you can learn what were the different changes. And as soon as Tal gives us heads up, we will be able to update the code base. You can also search on GitHub either within a repository or for a repository. You can also, if you are signed in and you have an account, you can watch a repository, and then you will have a notification each time there's a change or a new issue. If you, as a user, actually find that there's something wrong, or would like to propose a new feature in a piece of software, you can go to Issues, and you can create a new issue. You will need to have an account. Okay, I'm going to just sign in, and I don't remember my password. And all right, and I can now say change the name something or snappy. All right, and I can create this issue at NeuroSynth, and now Tal can interact on this issue.
Yeah, which I will do.
Which, and this is the kind of.
I got an email. So I just got an email. My pocket vibrated as Christmas.
So this way you can make his pocket vibrate. This is the most useful aspect. So now Tal can reply to my comment, which he's doing right now, coming up with as snarky comment as he can. Oh, yes. He says, oh, no. But I can now do, oh, my. Yes, someone took this seriously, it seems. And, okay. And you can tag people in the comments. So, for example, you can tag the whole organization. You can tag individual people. What's your handle, Daniel?
I didn't realize that people actually watching.
So now Daniel gets an email.
Really excited. Minding my own business.
And now you can make his pocket vibrate as well. Okay, so this is the interactive aspect of it, and then at the end you can actually close the issue if it's resolved. Issues can be closed automatically by comments, etc., etc. But this is kind of the best thing about GitHub because it brings people together, and you can get in touch with your favorite developers very quickly. So in the meantime, remember we've cloned this repository. But it's out of date right now, because if I do, if I look at this README file, it looks like this right now. But if I go online, I look at the comments. There's a new comment. It's called tweak README for GitHub demo, and I can actually, if I click on it, it will show me the difference between the two versions. I will highlight the deletions and the additions so you can quickly see what changed. If I go to the README file I have,
there's a very important change in so.
All right, so this is the thing I am sorry. And what did you change? Oh, the scikit-learn optional. Okay. So this thing is in my version, that piece of text. But if I go to GitHub, this comment deletes that particular comment in this file. So if I go to README, see, the scikit-learn doesn't have the optional comment in it. Yeah. So my version is different from the version on GitHub. We are out of sync. And what is more, if I go to Neurosynth, so the main repo, and look at the comments, the most recent comment is from today. And I go here and I do git log. The most recent comment, the comment is from September the 17th. So what do I have to do? Git pull. Do git pull. And this automatically updates my version with the changes made in the main repository. So this is how you can download software, interact with developers using issues, and update software on your local machine. Okay, are there any questions for this?
I have a comment. So, ideally, the command line is the best way to do this, but if you're learning, GitHub does actually have their own
client. There's a desktop client with buttons, and we didn't show it because none of us use it. We don't know how to use it. But it's there, and it's supposedly easier to use, and that might be the best way to start using it. But so from the receiving point of view, are there any questions on different? Is there anything else you guys think that I should describe here, Tal?
It's very confusing at first, but it starts to make sense after a while, so you just have to persevere.
Okay.
There's lots of demos on the web. I don't actually have a favorite one. There's a lot of ones.
There's a really nice game. Yeah. There's a game teaching you how to do Git. But what we're gonna do now, we're gonna.
I both figure the game is not.
It is something you learn on the job. you commit something, you pull something new, you're trying to collaborate, and all of a sudden you're Googling all over the place trying to figure out how to restore the repo that you just destroyed accidentally.
Yeah, and that, yes. Okay, so what we're going to do now, we're going to show you how actually work with the repository, so how to use it to version your own code, and how to collaborate with people, such as my lovely assistant. Okay, so what we're going to do first, we're gonna create a new repository. So I'm going to start new repository and do Brainhack in demo. Okay, make it public. Create the repository, and it basically tells me what I have to type in my terminal to get going with this repository. It's empty. There's no code in it. This is an assumption that I haven't written any code yet. So I'm going to take this, and I'm going to go. Okay. And I'm gonna create a new folder. And I pasted those commands. And what they did, they've created a README file. They initialized the GitHub repository, so that git init. So this file created a README file. This git init initialized the repository on the client side. Then we added the file. Then we committed the file. And then we pushed it to GitHub. Lot of things to take in. Just bear with me. It's all gonna make more sense in a minute. So now if I refresh it, actually there will be one file, that README file that I just added with those commands. This is the file. It has only this text in it. Let's say I want to make a change. Let's say I want to add some. And actually, on that topic, there's one thing that I'm going to digress a little bit. Speaking of changes, for small changes, you can actually contribute to projects without copying it using Git. You can contribute to things on GitHub itself. And I'm going to show you that right now. And then we're going to go back to the console. Sorry for this interruption. So let's say I go to Neurosynth again. I'm going to go to Neurosynth again. And I can see this file here. And let's say I want to suggest an edit to this file. So I press the edit button. So this is not my project, so I can only suggest modifications to it. And let's say I suggest that Tal should change the name of the project to Neurosynth XP. And now I can press propose file change. And this will summarize my change. And what I'm going to do, I'm going to create a pull request. I'm going to go back to those. But when I press this button, I can explain, at length what I'm proposing and why I'm doing this. And I can create the pull request. And now his pocket should vibrate again. And what he will see is basically a pull request. So pull requests are proposals with different additions and modifications of the software. And even if you are not, in the weeds in like actually making, sorry.
If you go to the page, they can see the tests fail in real time.
Oh, this is excellent. Did they fail?
It will.
Okay. Anyway, so this is what he sees, and here people can actually discuss the same way they discuss on an issue, they can discuss on the proposed changes. But because you can make those edits on GitHub itself, it's easy to make little things, correct little things. For example, is there a typo in documentation, and things like that. So I encourage you to do that. And here Tal can comment on this issue, and eventually he can merge it. He's still thinking about the name. It's not perfect. And eventually he can merge it. So this is how we can actually, this is the easiest way to give back, or easier way to actually not just take the code from GitHub, but actually contribute to different projects. But obviously, you cannot make big changes here. You cannot make changes that involve multiple files, and most often you will actually edit code, not text files, and you want to make sure that that code runs. So you're going to test your contributions before you suggest them to the owner. Okay, and that takes us to our text interface or console interface. So just to recap, we have one file in our repository, and what we're going to do now, we're going to edit this file, so I'm going to add a few lines. So I've made this change. I can save this file. And now if I do git diff, it will tell me what are the differences between the last snapshot of the code I made and current situation. And it says that I added a new line into the README. And what I have to do to actually push that change to GitHub, first of all, I need to create a snapshot. So I'm going to do, to do a snapshot, to make a snapshot, I have to tell GitHub which files should be included in the snapshot. So let's say I can add another file. I can add another file. Okay, I can add this other file, and let's say this is unfinished. Let's say I'm still working on it, but it's there. If I do git diff, that would only display the changes to files that were in the previous snapshot, but will not display files that were not snapshotted at any time in the past. So if I do git status, that actually distinguishes between those two cases. And here we have a modified file, so a file that I did version in the past, and I modified it. And we have a new file that I never versioned in the past. And now I've got full flexibility of deciding what should go into my next snapshot. I can add both of the files, or I can add only one of the files in the next snapshot. Think of this as framing a picture. All of this is basically photography of files. So let's say you have your project is your group of friends, and you're trying to frame a picture. And now what we're doing, we're deciding which of your friends actually make it inside the frame of the picture. And those will be part of the snapshot. So what I'm going to do, git add is the command to decide which files will be part of the snapshot. So I'm going to git add README. That changes the status. Before we had this category changes not staged for commit and untracked files. And here we have changes to be committed. And that means this file will be included in the snapshot. Since I have this, I can actually carry on and do the snapshot. So I do git commit. And now I can describe my change. And those are the descriptions you saw in the list of comments. Okay, so here I'm going to write something like added crucial text. And that is done. So if I do git status now, since I already snapshotted this file, the only changes I can see is this new file I've created and never tracked. Okay, if I do git log, I have two commits. The first one is the first comment, when I initialize the repository, and the second one is the change that we just made. This is all just on my computer right now because I haven't pushed it back to GitHub. So this is what I'm going to do now. Okay. Push it to GitHub, doing git push origin. Origin is the name of the repository.
Is that something you chose, origin, or is that?
This was chosen. This is the name is arbitrary. You can call it Amanda if you want. And yeah. So let me go to the demo. In the demo, I can see the changes here, and I can see those are the comments. And this is how can you snapshot your stuff and push those comments to the repository. But usually, at some occasions, you are contributing to a bigger project. And in such case, the workflow is slightly different. So let's say I'm going to show you a different project, kind of more of a real case. We can work with Neurosyn, actually. That's still good. So to start making bigger contributions, just like fixing a typo, you need to fork the projects. So what is forking? Forking is basically creating a copy of one repository within GitHub. So now there will be the central repository, the one that makes Tal's phone to buzz, and there will be your private copy of this repository that will make your phone buzz. To fork, I press the fork button, and I already forked it, but you basically select your account here, and that makes a copy. And you can see here that something changed. Before it was Neurosynth, and now it's Chris Philo, Neurosynth, because it's my copy of that repository. It's my fork of that repository. And it's fork from Neurosynth. To work with this, I have to clone it first. So let me take this handle, and we learn about cloning. All right. So it's being copied on my computer. We've learned about cloning, and what this copied here, as you probably noticed, is not the main repository, but my copy, because I'm cloning the fork, not the main repository. It's done. Okay. So if I do git status, it tells me that I'm on master branch, all up to date. There are no comments, no changes. Let's say I'm gonna go and start tinker with it. Any part of code I should break down?
All of it.
All of it. Reduce. And I can go here. Okay, I can do size plus 10. Here, this 1.2. This should be 1.1. Okay, saved. Let's tinker with more files. Yes. .utils and remove this. Okay, and should be 1. This should be 3. Obviously, I know what I'm doing. Okay, this is how coding looks, and here you can do def useless.
Actually, if you change, I don't know.
Self-define, eh?
Change something in base, and then you can see the test fail. When you...
Oh, okay. Okay, I don't know if it's actually up to date. So, but in base, which base? Analysis base?
Base.
Oh, base.
Base.
I can do. Oh, I can do this. That will screw you up. All right. So I made a bunch of changes. If I do git diff, they'll be all listed here, and we have all these changes. This is all I screw up with right now. If I do git status, I've modified 4 files. I haven't snapshotted them. I haven't included them in the snapshot. This is what I'm going to do now. So when you modify files, you can do git add for every single file separately, but there's a shortcut. you can actually assume that all the files that you modified should be included in the snapshot, which is usually the case. And that snapshot is a flag for the commit. So I do git-m as modified. Did commit-m, and that doesn't work because I am -a, which is, says here, commit all change files. Yeah, so it's not modified, but all. I'm sorry. All right, so git commit a. Here I say, what I'm going to say, performance improvements. Right. All right, do that, and now I do git push. Right. So I have pushed those changes. So let's refresh this. Let's have a look at this. Excellent. This you should include this in your software. Those changes will make your life easier. To do that, I press the pull request button. And here we'll compare my repository with his and show all the additions and deletions I've made. And I can do create pull request. And I create the pull request.
You want to explain the can't automatically merge?
Yes. So what happened here is that I used an old version of his code because I have forked it in May. And since May, he made a lot of changes. So I, assuming that he's a slacker and he will not make any changes, didn't update this repository for half a year. And now I woke up and make those changes. And now I'm telling him, hey, you should include those changes. But GitHub is smart enough to notice that he made a lot of different modifications in the past. And I need to update my code to be in sync with him and make sure that my changes do not interfere with the changes that he made in the meantime. We can fix that easily. So what we're going to do, we're going to add a new repository. Oh, sorry. I'm going to add a new remote. So, okay. So those are the remotes I have. So this local GitHub, local Git repository on my laptop is connected to my fork on GitHub. But I can add more remotes. For example, I can add tal, or actually the main one. So I can do git remote add. I'm going to call it upstream and do this. Right. And now we have two, origin and upstream. So now I can do git pull upstream. And this will update my code with the changes from the upstream, from the main repository. Okay. It tells me that I haven't specified which branch. So I'm doing this. We're not going to go too much into branches. Okay. And what happened now is something that rarely, but it does happen. Conflicts. Basically, the changes I made right now conflict with the changes that Tal did in the meantime. And that is inevitable when multiple people work on projects and the work is not divided very well. So here, what I have to do, I have to go into each of these files. For example, this one. And what you see here, this is the conflict. And this is my version, and this is his version. And what I'm going to do is basically say that his version is wrong and save it. And now I have to git add that file. And I have to do it for the other two as well. So I'm going to do this. Okay. Where is it? Oh my. Oh my. Yeah, he decided to remove the function I screwed up with, so I'm gonna put it back in. Okay, and plot utils. Okay. Again, I'm just gonna ignore the changes he made. All right. So I made this. Okay, sorry. Should do. And I have to do git add. Okay, reduce git add plot utils. Okay, so we had, whoa, okay. Let me just do this. Yes, so get at plot utils. So I've had 3 conflicts. I resolved the conflicts by basically ignoring them. There's one more. Okay. And this. So what is my status? There's a lot of changes because now I'm merging the 2 branches. And I do git commit. And this is the merge commit. So I don't need to write any messages, and git push. Okay, so this should update my branch with all the changes that Tal did in the meantime, and at the same time resolve any conflicts between the stuff that I changed and he changed at the same time. Okay, so going back here, and now this doesn't have this exclamation before that cannot be merged automatically because I've updated the software. What you see here as well, it's another feature that for every change I'm suggesting, tests will be run. So Tal wrote a bunch of tests that test whether new additions to the code break old functionality. And here you can see that those checks are pending, so those checks are running in the background. But at some point, this will turn from green to red, sorry, from yellow to red or to green, depending on the outcome of the test. All right. So this is the basic workflow when you actually try to contribute to a project. There is much more that you can learn. There's more functionality. I just wanted to give you a brief taster. But to really understand this tool, you have to start using it. The thing is that GitHub makes it very nice and very social and brings a lot of developers together. And I encourage you to use it on projects that you intend to collaborate with other people. Are there any questions? Yes?
Can you set permissions of who collaborates in projects? Like if I have my repository of my scripts, and I will come in and break all my stuff and screw.
Well, as you saw, what I did is I made the copy, screwed up with the copy, and said, hey, those are the suggestions. Would you like to include them? I have no permission to screw up with the main thing.
So who can really collaborate without forking it, without making a copy?
Okay,
you have to invite the person.
Yes, you can invite people, and you can set that. You can set that up. It's not the most common way of doing it. I actually send pull requests to repositories I am owner of, because this way it's easier to review changes. It's easier to track what has been added, and that also gives time for other contributors to comment on my additions. So yeah, so you can do it explicitly with permissions, or you can just use pull requests all the time. And I would recommend using pull requests. And if you have set up the automatic testing, that is also a good kind of staging process, because you make some changes, you make a pull request to your own repository, and then the test will run on it. And before you actually incorporate it with the main thing, you check whether it works, because the test works.
How do these tests work? Like if you have a function that returns some text, and the additions also return some text, but in a different formatting or something, how does the test know that something failed?
So there are many different frameworks for testing, and you explicitly say how similar or dissimilar the return values of functions should be. So there are some functions that, for example, are semi-stochastic or semi-random, and they will return things that are random. And there are certain functions that you expect only a certain precision from. So depending on different implementations, you allow to like stuff to change after like the 6th value after the comma, and you can all control that, or you can say like this function always has to return the number 42, and if it doesn't, that's a fail. Oh, the checks have failed, and you can go to details, and that will take you to a different website, and multiple different testing websites can be hooked up with the repository. And here, oh, sorry, this is very small. Let me just, okay. And here, there's a machine, virtual machine somewhere, and it starts running tests, and this is a failed test. And actually, it's a syntax error because while I was resolving conflicts, I forgot to remove this. So yeah. So this is a very kind of nice way of doing things.
Just to add to that, though, you have to write the test yourself. So
yeah, it's you have to write the test yourself. If that wasn't.
Really like, you're right. Like, you can write a test that doesn't catch. Generally,
yeah, you can write bad tests, and that doesn't make the software better.
You link those tests to particular areas of the project.
You can pull up a project maybe and you show the test. And Neurosynth does not have particularly good test coverage, so there are better examples, but you can see if you go to Neurosynth tests.
So test coverage is defined as a percentage of lines of code in your project that has been run at least once when you run all of the tests. So basically, if there is some code that is never run when you run tests, it means that it's never tested. And coverage is basically percentage of those lines. Okay. So this is how a test looks like. There's some kind of a setup. Here he suppresses warnings. And this is a simple addition you're doing here.
I don't think I wrote that in the art. So.
Okay, so this is a test that tests whether you can add correctly number 5 and number 3. All other digits are not tested. But it's a good example to, like, you know, what test is. So you basically have this function here, add 5 with arguments. It takes an argument and adds 5 to it. And here you run this function, and it has value, which is stored in variable I, which is terrible because you should all use full names for variables, as I said.
Oh, it's just test interpretation.
Yeah, and then you assert whether this value is equal 8. If it's not, the test will fail. Okay, so that's testing. Any other questions? That was fascinating. I see you being thrilled. This is like, I just want to go and commit and add and diff and branch and fork, and yes, you can all go and do that now. Right. Thank you very much. Wow.